All right, so we're working on the two variable inequalities now. I'm looking at this problem here where y is greater than or equal to a quarter x minus 3. And I can see that the slope is right there in the problem, 1/4, rise 1, run 4. The y-intercept is right there in the problem, -3. So I can start with a dot right there on the y-axis, and then I can go up 1 and over 4. I'm going to connect those dots with a solid line. The reason I'm connecting them with a solid line is because I had an equals to in my inequality. It did not just say y is greater than, it said y is greater than or equal to. So I have a solid line. Just like when we did number lines, I would have a filled in circle. Here, I have a filled in line. Then it says y is greater than. So I shade everything that is above the line because that's where the bigger y values are. That's my graph. Part B says test a point from your solution region. Solution region just means the shaded zone. If I look at my solution region, a point that's in there is 0, 0. Or I could have done 3, 1 or 17, a million. I'm just going to choose 0, 0 because zeros are fairly easy to work with. So I'm going to replace the letter y with 0, and I'm going to replace the letter x with 0, and I'm going to check if it's true or not. If I try a quarter times 0, I get 0. So all I need to figure out is if it's true that 0 is bigger than 0 minus 3. That is true, so that means I shaded the right area. I chose a point that was in the shaded area, and I got a true inequality. That means I shaded the correct area. Okay, here's the next one. It's level 3 now. It's a little bit harder to graph because it's not given to you in mx plus b format. You can either switch it to mx plus b format, or you can graph the two intercepts and connect your dots. I'm going to do it the second way, where I graph the intercepts and then connect my dots. What I notice is that 3 times 5 is equal to 15. So I know that if I make x equal 5, my inequality, 3 times x, will be exactly equal to 15. I'm going to put an open dot right there at 5 because I only have a greater than symbol. I don't have a greater than or equal to symbol. I also notice that -5 times -3 is equal to 15. So that tells me that if y is equal to -3, then my inequality will equal 15 on the left side and 15 on the right side. So I'm going to put an open dot down here at -3. When I have two dots, I can connect them, and I'm connecting them with a dashed line because it only says greater than, it does not say or equal to. I'm not sure which side to shade in, so I'm going to test a point now, and then I'm going to see if it works. I'm going to try testing the point 0, 0 again. This will tell me which side to shade. If I make x equal 0, I have to figure out what 3 times 0 is. I have to figure out what 5 times 0 is, and I have to see if that's greater than 15. 3 times 0, 5 times 0, and 0 minus 0 is 0. So ask yourself, is 0 bigger than 15? No, it is not. So I should not shade in the point 0, 0. I should shade in everything that is below the line instead. We can test a point now that's in our solution region, like for example, the point 3, -5. That's like way down here. So 3, -5. Let's try that one out. If x is 3, 3 times 3, and y is -5, -5 times -5, I'm checking if that's greater than 15. 3 times 3 is 9, 5 times 5 is 25, and yep, 9 plus 25 is going to be bigger than 15. So I tried a point that was shaded, and I got a true statement. so I shaded the correct zone. All right, let's look down at the other ones. Okay, so this one really tripped people up, writing an inequality where a couple points are solutions, but another point is not a solution. So let's start by just drawing a picture. -2, 3 is a solution. 2, 1 is a solution. And -4, -5 is a solution. So those points there are a solution. But the other point, 3, -3, is not a solution. So I'll put an X. I don't want that one to be a solution. So I want those 3 dots to be solutions, and I want the X to not be a solution. So here is one possible answer. I'm just going to draw a boundary line on there, and I'm going to shade above the line. This is not the only answer. This is just one possible answer. The boundary line that I drew is y equals 1x minus 4, because I have a slope of up 1 over 1, and I have a y-intercept of -4. I shaded above the line, and I drew a solid line. Above the line is why I wrote greater than, and solid line is why I wrote greater than or equal to. Okay? Now the last one of this type of problem, your sister is trying to raise at least $200, so I know there's going to be something that's greater than or equal to 200. By selling necklaces. She sells each necklace for $15, but has to pay a $25 fee for each farmer's market she attends. One possible inequality you could write is that she gets positive $15 times X, but she pays $25 times Y. And what I'm saying here is that the letter X stands for the necklaces, and that the letter Y stands for the markets. So I can do this problem just like I did the other one, where I find the intercepts, or I can graph it by switching it to mx plus b format. I'm going to do it that way because I already did the other method. That way you get to see both methods. So if I want this problem to be in mx plus b format, I'm going to get the y's by itself. I get the y by itself by getting rid of 15x. Then I divide both sides of the problem by -25 to get y by itself. 15 over 25, you can use a calculator if you want, or you can see that it's 3 times 5 and 5 times 5, so it's 3/5. So you can write 3/5, or if you grabbed a calculator, you could say it's 0.6. And then 25 goes into 208 times. Because I divided by a negative, I switched the direction of the inequality. So I'm going to draw a new x-axis on there because I have a negative y-intercept. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. There's -8. Then from that point, I go up 1, 2, 3 over 1, 2, 3, 4, 5. 1, 2, 3 up, 1, 2, 3, 4, 5 over. Solid line, shade below it because it says less than or equal to. Now I only shaded stuff that was above the x-axis that I drew because it doesn't really make sense to have a negative number for y. Y is the number of farmers markets, so she got to go to at least one farmer's market. Here are a couple combinations that would work. She could sell 1,000 necklaces and go to one farmer's market. She could sell 200 necklaces and go to 2 farmers markets. Or she could sell 20 necklaces and go to 4 farmers markets. I think that works. 20 necklaces times $15 is 300. 4 farmers markets is 100, so that would be right on the boundary. So thanks for watching. Let me know what else I can do to help. Please ask questions.